In this lesson, we are going to learn about the transpose of a matrix. The transpose of a matrix is simply a flipped version of the original matrix. So let's look at what that means. Let's say I have a matrix A, which is equal to 1, 2, 3, 4, 5, 6. Okay, and then we'll be asked to find the transpose of this matrix A here. How are you going to do this? To find the transpose of this matrix, all we have to do is to change the rows to columns. Okay, to change the rows to columns. Okay, or you can also say that you will change the columns to rows. Okay, so when perform any of these two operations, that will give us the transpose of what this matrix A here. Okay, so let's look at how you are going to do this. So for this matrix A here, it has what, two rows, right? So I have row 1 here and then row 2 here. Okay, so to find the transpose of this matrix, all I'll do is to change the rows to what, columns, which means that I'm going to rewrite the values vertically. Okay, so you see that in this case they are written horizontally. Okay, the values that I have circled have been written horizontally, but to find the transpose of the matrix, we are going to write them vertically. So that will give me 1, 2, 3, and then 4, 5, 6. So therefore, this will be the transpose of what? The matrix A. Okay. Similarly, we can rewrite we can change the columns to rows. Okay. We can also change the columns to rows. So let's look at how we're going to do this. So this is column 1, this is column 2, and then this is column 3. Okay. So you see that these values have been written vertically. Okay, so I'm going to rewrite them horizontally. Okay, so let's look at how we are going to do this. So in doing this, okay, let me say, or in doing this, we are going to have, so we are writing the vertical values horizontally. So I will have 1, 4, and then 2, 5, and then 3, 6. Okay, so this will also be what the transpose of what the matrix A. So it's either you change the rows to columns or the columns to rows. Okay, that will give you the transpose of what, of a matrix. Let's look at another example. So let's say I have matrix B here, which has the entries 1, -3, 4. Okay, and then 5, 6, -2. So these are the entries of this matrix B here. And then we've been asked to find the transpose of this matrix B. So all we have to do is to rewrite the rows into columns. Okay, so in that case, we have row 1 here, okay, and then row 2 here. Okay, so I couldn't really circle it well. Okay, but let's manage it. So rewriting row 1 vertically, I will have 1, -3, and then 4. And then also rewriting row 2 vertically, I will have 5, 6, and then -2. So this will be the transpose of what? This matrix B. Okay, so now let's go ahead and then look at some properties of the transpose of a matrix. So one property is that when I multiply a scalar by a matrix and I find their transpose, it will be the same as multiplying the scalar by the transpose of what? Of the matrix. So let's look at what that means. So I have this here. So what this means is that when you have a scalar A which is being multiplied by a matrix M, okay, and then we take its transpose, it will be the same as we multiplying the scalar by the transpose of what? The matrix M. Let's try an example to see if this is true. So I have the scalar A which is equal to 2, and then I have the matrix which has the following entries. So we have 2, 3, 4, and then 5, 6, 7. Okay, so this is matrix M. So now let's find the product of matrix M and then the scalar A. So A by M, okay, will be equal to 2 times the matrix M. So that will be 2, 3, 4, 5, 6, and then 7. Okay, so when I do this, this will give me, I'm going to multiply the scalar by each of the entries. So 2 by 2 give me 4, then 2 times 3 will give me 6, and then 2 times, okay, 2 times 4 give me 8, and then 2 times 5 will give me 10, and then 2 times 6 will give me 12, 2 times 7 will give me 14. Okay, so after doing this, then I'm going to find the transpose of what? A by M. Okay, so when you do this, you are going to write the rows into columns, right? So I will have 4, 6, 8, and then 10, 12, 14. Okay, so this is what I will have. So now let's see if this will be the same as what we find the transpose of what the matrix M and then multiplying it with the scalar A. Okay, so let's find the transpose of the matrix M. So the transpose of the matrix M, we are going to have 2, 3, 4, and then 5, 6, 7. Okay, so let's multiply this transpose by the scalar A. So A times the transpose of what? The matrix M. So A is 2. Okay, so I multiply 2 by 2, 2 by this 2 here, I will have 4. Okay, when I multiply 2 by this 5 here, that will give me 10. And then I'll multiply 2 by this 3, that will give me 6. And then I'll multiply 2 by this 6 here, that will give me 12. And I'll multiply 2 by the 4 here, that will give me 8. And then I'll multiply 2 by this 7, that will give me 14. So then you see that this value that we got here, okay, is the same as what? This value that we got here. So that means what? This property is true. Okay, so you can see that therefore multiplying a scalar A by the matrix N will be the same as multiplying the scalar by the multiplying the scalar A by the matrix M and then taking their transpose will be the same as what? Multiplying the scalar A by the matrix M, okay, by the transpose of what? The matrix M. Okay, so this means that this property is true. Okay, let's look at another property. So I'll write down the property here. Okay, so this property is saying that when we take the transpose of a matrix M and then we take its transpose again, we're going to get the matrix itself. Okay, so let's look at what that means. So let's take an example. So I have the matrix M to be equal to 2, 3, 4. And then I have 5, 6, 7. Okay, so let's take the transpose of this matrix here. So the transpose of this matrix will be 2, 3, 4, and then 5, 6, 7. Okay, so what you are going to do is that we are going to take the transpose of what? The transpose of what? Matrix M. So that will be M transpose transpose. So doing this, I'm going to have 2, 5, 3, 6, and then 4, 7. So you see that what? After doing this, we got the matrix again. So therefore, this property is also true. Okay, let's look at another property. So I will go ahead and then write down the property. Okay, so this is the third property of the transpose of a matrix. So it says that when I have two matrices M and then N, and then I take their sum and then take the transpose of their sum, it will be the same as me taking the transpose of the matrix M and then the transpose of what, the matrix N, and then summing them up. Okay, so now let's go ahead and then take an example. So I have this matrix M here, which is equal to 2, 3, 4, 5, 6, 7. Okay, and then I have matrix N, which is equal to 8, 9, 10, 11, 12, and then 13. Okay, so let's find M plus N. Okay, so adding matrix M and then N will give me the following values. Okay, so I have 10, 12, 14, and then here also I will have 16, 18, and then 20. Okay, please, if you don't understand how I did the addition, you can watch the video on how to add two matrices. I have the link in the description. I want to make everything short, so I won't talk about how to perform the addition here. So please, if you don't understand how to perform the addition, please check in the description. You'll find the link there. Then you watch the video on how to perform addition on matrices. Okay, so after performing the addition, I'll get these entries. So we are going to take the transpose of the sum of the matrix M and then N. Okay, so when I do this, I'm going to have 10, 12, 14. Okay, and now I have 16, 18, and then 20. Okay, so now we are done. So now let's take the transpose of the matrix M. Okay, so let's take the transpose of what, the matrix M. When I take the transpose of the matrix M, I will have 2, 3, 4, and then 5, 6, 7. And then for the transpose of the matrix N, I will have 8, 9, 10, and then 11, 12, and then 13. Okay, so let's add these two values. So M transpose plus N transpose. Okay, when I do this, I'm going to have 10, 16, 12, 18, and then 14, 20. So you see that the value you got for this is the same as what the value you got for this. So therefore, this property is also true. Okay, so now let's look at the last property for the transpose of a matrix. Okay, so we are now going to talk about the last property of the transpose of a matrix. So that also says that when you take the product of two matrices and then you find their transpose, it will be the same as performing the inverse multiplication, okay, of the transpose of the second matrix by the transpose of what, the first matrix. Okay, so that's what is happening here. So let's take an example. So let's say I have the matrix M given to be 2, 4, 6, and then 8. Okay, and then matrix N given to be 9, 10, 11, and then 12. Okay, so when I find the product of these two matrices and then I find their transpose, it should be the same as what you have on the right hand side here. So let's do that and see. I'm going to find the product of these two matrices. Okay, when I find the product, I'm going to have I'm going to have 6, 2, 6, 8, and then 142, and then 156. Okay, so this will be the value after performing the multiplication, and then we are going to take the transpose of what, this product. So that will be the transpose of what, this product. So I'm going to have 6 2 6 8, and then 1 4 2 1 5 6. Okay, so that was the result after taking the transpose. Now let's find the transpose of what? Matrix M. The transpose of matrix M will be 2 4 6 8, and then let's find the transpose of matrix N. That will be 9 10 11 12. Okay, so now let's find this product. Okay, so let's do this. When I perform this product, I'm going to have 6 2 1 4 2, and then 6 8 1 5 6. So and then you see that what you have here, okay, this match what we have here. So therefore this property is also true. So what we talked about were the properties of the transpose of a matrix. Thank you very much for watching this video.